Welcome back, and we're going to get started on the second order reaction, and I have kept the same reaction but changed the question a little bit. We got two different questions here, and I'm asking you, what is the rate law expression? Technically, this would appear at the end of this or as a separate equation, as a separate question on its own. Because I've already told you the reaction is second order with respect to ammonia, it so happens that this is also 2, but that's not why we are saying the reaction is second order. It's experimentally determined. So in that case, rate equals K. It's always K. That's the way we write. And then we write whatever the reactant is and write its second order. So the rate law expression is this. Now, it so happened that there is a 2 here, okay? No matter how carefully I choose an example, there's always going to be a case where there's going to be some coincidences, but please don't let the coincidences get in the way of your understanding. Here I have specifically said the reaction is, I could have been even more specific, say second order with respect to NH3. Okay, so writing a rate law expression, I just want to keep in touch with what I introduced in the very first video. So this is how you write a rate law expression. Okay, now let's actually get to the problem. If the above reaction is second order and the second order rate constant is this, you see it's m minus 1 s minus 1. So m minus 1 indicates the reaction is second order. As I said, if the reaction is second order, okay, the rate constant would be m minus 1 s minus 1. It'll be minus 1. M will be 1 if it's second order. If it's third order, m would be negative 2. Okay, s is always minus 1. So this is one way to tell my reaction is second order, and the concentration of NH3 at start is this. What is the concentration after 30 minutes? Now, if you remember, again, this is the equation. You do not have to remember this. This is for second order. This will be in the appendix. But how to use it is what you really need to know. So what we need to find is this. This AT is the concentration at a particular time. What we know is at start, concentration is 0.73. And time is 30 minutes. We'll get to that in just a second. And we also know K is 2.5 e to the negative 4. So we know all but AT. But there's a catch here. So M is, this is in seconds, whether it's minus 1 or not. Nevertheless, this is in seconds, this is in minutes. We got to convert minutes back to seconds. I always convert my T. So it's 30 minutes over 1. And 60 seconds is in a minute. So sorry if all this sounds very trivial, like minutes to seconds stuff. So 30 times 60 is 1800 seconds, right? That's right. Now this is our new T value. So let's go apply all of this. 1 over AT, let's leave it be, equals 1 over 0.73 plus your K value is 2.5 e to the negative 4 times T is 1800 seconds. Now, people that write these tests know very well that not every student is going to convert the minutes to seconds. That's why they purposefully give these problems. Now, your classroom teacher might always make life easy for you because he or she wants to please you by giving the perfect exam where you can get an A. I don't like to please my students, so I give what is best for them on the long run, not just to pass my class. So this is how people outside of my class will test you. They want to see if you pay attention to detail on every question. And if you don't, well, chances are you're just going to multiply everything. And then you see there's an answer choice that's sitting right there with the incorrect calculation, and you go for it. And that's the way that's what 100 people take that exam. Only 5 or 10 will get out of it because those are the number of people that actually pay attention to detail and actually finish the problem. So let's go and finish this one. Times 1800 plus 1 over 0.73. So it's about, so this value, whatever it is, 1 over this AT, this whole thing is equal to 1.819. But we want AT, right? So it's 1 over 1.819. Again, I'm not going to go through why we're doing this. That should have been taken care of by your math teacher. So 0.549. Now, if you see, again, I'm being consistent. We're starting, your concentration every second will be lower than what you start with. We started with 0.73. At the end of 30 minutes, we have 0.549. So clearly, it's gone down. So we have most likely done this problem right. Now, again, what you have to pay attention is not the equation. This will be given to you. And then it's only focusing on the K unit, and then pick the correct equation to solve it. And so I'll see you with, I'm going to combine the remaining two material probably into a single video, or keep them separate depending on how much faster I can get through that material. All right, so stay tuned for zero order reaction.